Assalamualaikum and hi student. So today I'm going to show you a mechanism of benzene. So the first one is the halogenation of benzene. Okay, for this reaction, we will use benzene ring, halogen, bromine, and the presence of Lewis acid. Okay, and the product form is bromobenzene, side product HBr. Okay, for the mechanism of halogenation of benzene, there are three parts. Okay, the first one is formation of electrophile. Okay, formation of electrophile. So for this reaction, the electrophile will be halogen. Okay, halogen positive. And for this reaction, bromine plus is a electrophile. Okay, so Lewis acid, okay, is a catalyst to polarize the halogen molecules. Okay, Lewis acid is a lack of electron species. Thus, it will attract electron from halogen molecule to form a complex. So now we show the formation of complex, right? So we are plus with Lewis acid. Okay. So we show the arrow from the one of lone pair of bromine to Lewis acid, and then complex form. FeBr3. And the bromine here will be positive, and the Fe will be negative. So this one is a complex. Okay, so we go to the second step, which is formation of rhenium ion. Okay, the complex will dissociate to form halogen ion and FeBr4. Okay, the halogen ion will attack benzene to form rhenium ion. So the arrow will be so this arrow goes to Br, and lone pi electron of benzene goes to the bromine. Okay, for the rhenium ion, we have to draw 3 resonance because of pi electron will be delocalized. Right? So the first one here, we show the arrows. Okay. So positive here, and this pi electron will go between these two carbon. Okay, this will be positive, Br and H. Okay. Alright, this is rhenium ion, and last with FeBr4 minus. Okay, lastly is a removal of a proton from rhenium ion. So the nucleophilic here, okay, FeBr3. Okay. Alright. Last with HBr and FeBr3. And now we get a new product. This is a side product, HBr, and we gain back Lewis acid as a catalyst. Alright, okay, now we go to the second mechanism of benzene, which is nitration of benzene. Right, for this reaction, concentrated nitric acid with a catalyst concentrated sulfuric acid is needed for this reaction, right? And also you have to write down the condition, okay, 50 to 55 degrees C. Okay, so for the first step is formation of electrophile, and for this reaction NO2 plus is a electrophile, right? So we show the arrows, okay, oxygen, electron pair of oxygen goes to hydrogen, and right, and this will form. Alright, so second step is formation of rhenium ion. So we show the arrows from benzene, okay, goes to nitrogen ion, and rhenium ion will form. Okay, please remember, you have to draw 3 rhenium ion because of delocalization of electron. Okay, resonance. So here double bond here, positive charge will be here, NO2, H, and last one. Okay, show the arrow comes to this one. Positive charge here, NO2 and hydrogen. Okay, this is rhenium ion. And the last part of this mechanism is removal of proton from rhenium ion. Okay, for this step, we use HSO4 minus, right? Okay. Alright. And product form is nitrobenzene and sulfuric acid. Alright, that's it. Alright, so the third reaction of benzene is a Friedel-Crafts alkylation of benzene. Okay, so I'm using this reaction to show the mechanism of Friedel-Crafts alkylation. Okay, so for the first step of the mechanism is formation of electrophile. And for the Friedel-Crafts alkylation, carbocation is an electrophile. Right, so this is a Lewis acid, act as a catalyst. Okay, function Lewis acid is to increase the polarity of chlorine and to form carbocation. So we show the arrows, okay, CH3. But before carbocation is formed, we have to show the complex first. Okay, so chlorine positive and this aluminum will be negative. And to form carbocation, so the electron between carbon and chlorine, it goes to the chlorine. And CH3, CH3, H positive charge, and AlCl4 minus will form. Alright. Alright, so the last part is removal of a proton from the rhenium ion. So same as the previous mechanism, right? So okay, so we just show the removal of hydrogen, okay, by using Lewis acid. Okay. Right. Okay. CH3 plus with the side product HCl and Lewis acid. Okay. Alright. For the Friedel-Crafts alkylation, if the haloalkene is a methyl halide or primary haloalkene, so the first step only involve the formation of complex and no carbocation will be formed. Second step, the benzene will react with the complex and form rhenium ion. And the last part, same as the previous, which is removal a proton from the rhenium ion. Alright, so this is a last reaction for the benzene, which is Friedel-Crafts acylation of benzene. So same as the previous mechanism of benzene, there are still three parts, which is the first one is the formation of selenium ion, the second part is formation of rhenium ion, and the third part is removal of proton from rhenium ion. Right, so this for this reaction, the electrophile will be alcylium ion. Okay, which is you have to show the arrows from the chloride ion to the Lewis acid and form a complex. Then to form alcylium ion, so you have to show the bond breaking here, okay, between carbon and chlorine. And this one, chlorine will be positive, okay. And alcylium ion will be 2 ion because of resonance will occur, okay. So this one, this is alcylium ion, okay, resonant alcylium ion. And the second part, formation of rhenium ion, so you have to show the arrows from the benzene to the alcylium ion and form rhenium ion. So you have to draw 3 structure. And lastly is removal of proton, okay. So using this Lewis acid nucleophile, okay, AlCl4 minus. So we show the movement, the electron, okay, from the chlorine to the hydrogen, and this electron will enter to the benzene ring, and bond breaking will be here, and we get the product, side product, and Lewis acid. That's all.